let f of x equals 2x plus 1 whole cubed, and let g be the inverse function, the inverse of f. Given that f of 0 equals 1, what is the value of g prime of 1? So we have this function f of x, and we have this function g of x, and we're told that they are inverses of each other. And what inverses mean is that the xy coordinates have been reversed. If we have some function f with coordinates fy, xy, then the coordinates of its inverse, say g, which is equal to the inverse of f, then its coordinates are the coordinates of fy, but reversed. This is equivalent to reflecting a graph across the line y equals x. That's what the inverse is. So if we have a parabola like this, then reflecting it gives us a parabola like this. And that's the same as reversing the xy coordinates. So we're told that f of 0 equals 1, and that we need to find the value of g prime of 1, meaning the value of the inverse function of f at an x value of 1. And we can do that using the information they gave us, that f of 0 equals 1. So on the graph of f, the coordinate of this point is 0, 1. When x is 0, f of x is 1, or y is 1. So that means on the graph of g of x, which is the inverse of f, when x equals 1, g of x equals 0, since they are inverses, their coordinates have been reversed. So in the graph of g of x, when x is 1, y, or g of x, is 0. So that means that in order to find the value of g prime at 1, we would need to use the formula for the derivative of the inverse of a function, which says that if we want to find the value of g prime at some x, we can take the reciprocal of its inverse evaluated at that x value that g of x returns. So when x equals g of x, we need to find the value at g of 1. So we're told that f of 0 equals 1, so that means that g of 1 has to equal 0. So in this case, we need to evaluate f prime at x equals g of 1. So that means g of x at x equals 1 equals 1 over f prime evaluated at x equals 0. Because g of x equals 0 when x equals 1. So to find the value of f prime at 0, we can take this function f of x and take its derivative. So f prime of x is equal to, we'll do a power rule here. So we multiply by the exponent, keep the base of the exponent the same, subtract 1 from the exponent, so now it becomes a 2. Then we have to multiply by the chain rule piece, and in this case, the derivative of 2x plus 1 is just 2. So that means our derivative is equal to 6 times 2x plus 1 whole squared. So this is our function f prime of x, and we want to find the value of f prime of x at 0. So f prime at 0 is equal to 6 times 2 times 0 is just 0. So inside we're just left with 1 squared, which is just equal to 1. So that means that at an x value of 1, we can just rewrite this as g prime of 1. The x equals is omitted, is equal to 1 over f prime evaluated at x equals 0, which is equal to 6. So g prime of 1, where g is the inverse of f, is equal to 1/6. So D is the correct answer.